Welcome to the screencast for 5.3, the study guide. So this whole section is about solving trig equations. So here we're going to be trying to find the values of where the trig functions are equal to a certain number. So for example, here with this first one, we have tangent squared x equals 1. So if I square root both sides, I get tangent of x is equal to plus or minus 1. So we could take this two ways. I can solve for when tangent of x is equal to positive 1, and I can solve for when tangent of x is equal to negative 1. So think about where is tangent equal to positive 1? At what angles? Well, tangent is equal to sine over cosine. So you're thinking, where does sine and cosine equal each other? Well, it has to be at a 45-degree angle, but tangent is positive. Let's see. All students take calculus. Tangent's positive in the first and the third quadrant. So it's going to be a 45-degree angle for x equals pi over 4. And we're going to have this angle down here. So we have the 45-degree angle, and we have the one way over here, which is pi plus 45. So that's 5 pi over 4. And it says for all values of x, so I need to make sure to add 2 pi n onto both. Okay, so that's half of it. We solve for when tangent of x equals positive 1. And keep in mind, where did this positive negative 1 come from? It's coming from the fact that we have a squared. When I square root both sides, I'll have the negative number squared is tangent squared, and then the positive one squared is also going to be tangent squared. In a similar vein, you can say the square root of 4 is equal to plus or minus 2. If I have minus 2 and I multiply it by minus 2, I get positive 4. If I have positive 2 and squared, I get positive 4. So that's why I'm going to have 4 solutions. So for my other one, for tangent of x equals negative 1, I'm thinking, where is tangent not positive? All students take calculus. So tangent is going to be negative in these two quadrants. If you think to yourself, this kind of makes sense because here I'm going to have a negative x, but I'll have a positive y. And so that will make, when I have sine over cosine, I'll have a positive sine, a negative cosine, so total negative tangent. And then down here, I will have a negative y and a positive x. This corresponds to a negative sine and a positive cosine. AKA, then we'll have a negative tangent. So also notice tangent is not listed as positive here. So we already know that sine and cosine will equal each other at pi over 4. So if I want to know what this angle is, I need, well, this reference angle is 45. But to get over there, that angle will be 3 pi over 4. So x is equal to 3 pi over 4. But we have to have all solutions, so plus 2 pi n. And then we also have this other angle that goes all the way around. So that's going to be 7 pi over 4 plus 2 pi n. Oops. So here are my other two solutions. So this keeps track of all values of x by adding the plus 2 pi n. You know, tangent will equal 1 or negative 1. Because tangent is equal to sine over cosine. So where does sine and cosine equal each other? They equal each other at a 45, 45, 90 triangle. So the difference between the positive and negative is if you have a negative sine and a positive cosine, you'll have the negative tangent. Vice versa. Alright. You go ahead, pause this video if you need to. Try out the next one. What I'm going to do now do number 2. So I have 2 sine squared x minus cosine x equals 1. This sucks. I need to have everything in the same trig value. Since I can't change cosine into something with sine, I'm going to have to change sine into something with cosine in it. Well, I know sine squared theta is equal to 1 minus cosine squared theta. So I'm just going to plug that in place of sine. So I have 2 times 1 minus cosine squared x minus cosine x. And I'm just going to bring this one over to the other side. So minus 1 equals 0. I need to go ahead and distribute out this 2. So I'm going to have 2 minus 2 cosine squared x minus cosine x minus 1 equals 0. I need to combine like terms. So the 2 minus a 1 goes to a positive 1. And then I have negative 2 cosine squared x minus cosine x plus 1 equals 0. So I'll come over here to the side. Do I know how to factor negative 2x squared minus x plus 1 equals 0? So instead of saying cosine x and cosine squared x, I'll say x and x squared. Since I'm trying to relate it to how you know with algebra. Well, this is kind of hard, but if I multiply everything by negative 1, I'll have 2x squared plus x minus 1 equals 0. That's a little easier to factor. So I know 2x times x is 2x squared. The factors that equal a negative 1 are positive 1 and negative 1. The question is, which one should be linked with the 2 from FOIL? First, outer, so which one will be the one that's outer? Since I will have a positive x, I'm going to say this is my plus 1. Then over here has to be my negative 1. And just to make sure, I can FOIL. So first is 2x squared, outer, plus 2x, inner, minus x, last, minus 1. So 2x minus x is a positive x. Cool. I know I did it right. Okay, so I want a 2x. So here that's going to be 2 cosine x minus 1 multiplied by x plus 1. So cosine of x plus 1 equals 0. Set each term to 0. So I'll have 2 cosine x minus 1 equals 0. Add 1 to both sides and divide by 2. Add 1, divide by 2. Add 1 on both sides, so I move that guy over and then divide by 2. Alright, so where is cosine equal to 1/2? All students take calculus. So positive half. So these are where cosine will be positive. So what angle is this? If you already know off the top of your head, you don't need to draw this triangle, but this is in case you forget. So I know SOHCAHTOA, cosine is adjacent, 1/2 over hypotenuse of 1. Starting to recognize this triangle. So hold up, this is going to be 60 degrees. So 60 degrees is the same thing as pi over 3. Let's see, I have to find for all values of x. All values. Okay, I can do this. So I know x is going to equal pi over 3 plus 2 pi n. The plus 2 pi n takes care of all other values. Like however many times I want to go around the circle, that's what the 2 pi n takes care of. My other angle, alright, so this pi over 3 is going to be this guy that goes there, but then my other angle goes all the way over here. So it's going to be pi over 3 less than 2 pi around. So here my x is going to be 5 pi over 3. And of course you have to add the 2 pi n because it says all values. Alright, so that's half of my solution. The other half is going to be cosine of x plus 1 equals 0. Minus 1 from both sides. Cosine x equals minus 1. Where is cosine equal to minus 1? Pi. So x will be pi plus 2 pi n. So I have 3 solutions. When it says find for all values of x, that means plus 2 pi n. Alright, let's keep going. So I want you to try out this next problem, and I will pause it here to work out the first part. You want to pull out a cosine x because that's a common term. So I have cosine of x times sine of x minus 3 equals 0. So I'll set cosine of x equal to 0. Where is cosine equal to 0? Where is cosine equal to 0? Well, let's see. Oops. Where is cosine equal to 0? Cosine's x. So 0, 1, and 0, -1. So I have pi over 2 and 3 pi over 2. Plus 2 pi n, plus 2 pi n. Alright, that's where my cosine's equal to 0, because that's where x is equal to 0. Now the other term is sine of x equals -3. So sine of x minus 3 equals 0. Sorry, so sine of x, you add 3 to both sides. So where is sine equal to 3? This is a trick play. There's nowhere where sine is equal to 3. So this does not, it doesn't exist. There's no angle where sine can equal positive 3. Because sine only goes between -1 and 1. So we only have 2 solutions for this guy. This next one, you can go ahead, pause it, try it out. So here I have cosine squared x plus sine of x plus 1 equals 0. There's nothing I can sub in for sine of x because it's by itself. It's not squared, it's just by itself. And I need to get everything in the same trig function, so which means I can sub in something for cosine squared of x. So I know cosine squared theta is equal to 1 minus sine squared theta. This is just a Pythagorean identity, so I'm plug that in, 1 minus sine squared, x, plus sine x plus 1 equals 0. Oh my gosh. Alright, so if you have 1 and add 1, you get 2. So we have minus sine squared x plus sine of x plus 2 equals 0. If I multiply by everything by -1, it's the same thing as moving everything to the right side. So I can have sine squared x minus sine of x minus 2 equals 0. So I can come over here and try solving it with algebra, like how you've solved it before. X squared minus x minus 2 equals 0. Let's see, I have x minus 2, x plus 1. Let's see, does that work? So if I FOIL it out, I have x squared plus x minus 2x minus 2. X minus 2x is -x. Check. We're doing good. We're solid. So let me plug it back in. So I have sine of x minus 2 and sine of x plus 1 equals 0. I'm going to set each one equal to 0. So sine of x minus 2 equals 0. Sine of x equals 2. WTF, this does not exist. There's no place on the unit circle where sine is equal to 2. So that's a non-starter right there. Alright, the other one. Sine of x plus 1 equals 0, minus 1 from both sides. Sine of x equals -1. Where does sine equal -1? Where is my y? -1. X is equal to 3 pi over 2 plus 2 pi n. This was a question that was exactly on the quiz. Cool, except that actually I think this was the exact question I put on the quiz. Alright, so let's keep going. Let's see. Sine of x equals cosine x. Oh my gosh, this is ugly. Well, I could ask myself, where does cosine equal sine? There's 2 ways to solve this. You could say, oh yeah, I know cosine is equal to sine at 45 degrees. And they have to have the same SIGN, so positive and negative. So there's only going to be 2 solutions. So I already know the solution for this will be pi over 4 and 5 pi over 4. Because those are the only places on the unit circle where my x and y have the same sign. So in my first quadrant, I have positive x, positive y, and in my third quadrant, negative x, negative y. So those are going to be my only 2 solutions, but let's go through and look. So if I square both sides, I'll have cosine squared x equals sine squared x. Let me sub in eeny, meeny, miny, mo. Okay, let me plug in 1 minus sine squared for cosine. 1 minus sine squared x equals sine squared x. Subtract sine squared x from both sides. 1 minus 2 sine squared x. Oh, yikes. Maybe I'll do it the other way. Yeah, so I'll add. So I'll have 0 equals 2 sine squared x minus 1. That's super ugly. Alright. Why did I do this? Add 1 to both sides. 1 equals 2 sine squared x divided by 2. 1/2 equals sine squared x square root both sides. So I have this square root. So 1 square root of 1 is 1 over square root of 2. Don't forget plus or minus because we square root equals sine of x. So it's asking where is sine equal to positive or negative square root of 2 over 2. So that's another way of saying it. If I rationalize it, this would be square root of 2 over 2, plus or minus. So there's 4 places where that could happen. So it would be this angle, which is pi over 4, that's 45 degrees. We could have 3 pi over 4, which is also 45 degree reference angle. I could have 5 pi over 4, which once again, 45 degree reference angle. And I can have 7 pi over 4 because it's 45 degree reference angle. So I should have 4 solutions apparently, but I introduced erroneous solutions, extraneous solutions when I squared. So I'm going to have some that actually don't work after all. Okay, the only way to solve this is literally plug in each of my 4 equations into my original cosine of x equals sine of x. So if I plug in cosine of pi over 4 equals sine of pi over 4, we know that's true, right? Square root of 2 over 2 equals square root of 2 over 2. That's fine. So I know, oh, we only have to find it on the interval. Perfect. So I know x is going to equal pi over 4. In the same vein, we can try 3 pi over 4, but you can already tell here my cosine will be negative, but my sine will be positive, and so it won't work. Alright, so cosine of 3 pi over 4 is not equal to sine of 3 pi over 4, and that's because negative square root 2 over 2 is not equal to positive square root 2 over 2. So that's why this guy gets struck. Alright, so 3 pi over 4 is, oh my god, is not a solution. I know 5 pi over 4 will be. I'm running out of room. So cosine 5 pi over 4 equals sine 5 pi over 4 because negative square root 2 over 2 is equal to negative square root 2 over 2. Cool. So that one works. 5 pi over 4. That one works. Check, check. And then 7 pi over 4. Pain in my butt. Alright, so cosine 7 pi over 4 is not going to equal sine of 7 pi over 4 because, let's see, positive square root 2 over 2 is not equal to negative square root 2 over 2. It's like saying positive 1 is the same thing as negative 1. It's not going to work. So this guy is not a solution. These are only 2. And from the start, that's what we thought they would actually equal. Alright, so now here's number 6. Go ahead, pause the video. I'm going to do some algebra, pause the video. So I'm going to try to rush a little bit so this video doesn't go too long. So I noticed that I have a cosine in both terms, so I'm going to pull that out front, a factor out front. So I'll be left with 3 square root of 3 tangent minus 1. I set cosine x equal to 0. Try to figure out where cosine's equal to 0. So I notice on my unit circle it's going to be pi over 2 and 3 pi over 2. Those are the only places cosine of x is equal to 0. And then I'm going to set square root of 3 tangent x minus 1 equal to 0. So I add 1 on both sides and then divide by square root of 3, so tangent of x is equal to 1 over square root of 3. So I'm like, well, maybe you forgot what angle that is. So I draw out the triangle. I know my opposite side is going to be 1. My adjacent side is square root of 3. I do Pythagorean theorem. Square root of 3 squared is 3, plus 1 squared is 1, 3 plus 1 is 4. Square root that, and 2 is going to be my hypotenuse. So I'm going to make a similar triangle, because maybe you still don't recognize it, so I'm going to divide every single side by 2, and then I get the triangle that's on bottom, which is one that we've studied numerous times. So you can tell the angle we're actually talking about is going to be 30 degrees. So that's pi over 6. And then also we have that angle that's in the third quadrant that's positive for tangent, and that will be 7 pi over 6. Alright, so second to last, we have tangent squared x plus secant x minus 1. Go ahead, pause the video, and then I'll write the solution and explain it. Alright, so here I have tangent squared x plus secant x minus 1 equals 0. So in place of tangent squared x, I put secant squared x minus 1. Because I know tangent squared x plus 1 is equal to secant squared. So to solve for tangent, I just subtract one of both sides. Anyway, I'll have secant squared x plus secant of x, and then I have minus 1 is total of negative 2. I came over here, factored it with algebra. So now x squared plus x minus 2 factors into x plus 2, x minus 1. So I put secant x plus 2 times secant x minus 1. Back over on the left side. So I get secant of x equals negative 2. I don't know what that is off the top of my head, but I do know secant is the reciprocal of cosine. So if secant is negative 2, cosine will be negative 1/2. So I ask myself, where is cosine equal to negative 1/2? All students take calculus. These two quadrants are where cosine is negative. It's where x is negative. So I know that my adjacent side is going to be 1, and my hypotenuse is 1, my adjacent side is negative 1/2. We recognize this is a 30, 60, 90 triangle. Since the adjacent side is the 1/2, the opposite angle has to be 30, so the angle we're interested in is 60. So 60 degrees is the same thing as saying pi over 3, except that's not exactly our angle. Our angle is going to be from 0 to that terminal. So it's going to be pi minus pi over 3. So the angle we're interested in is 2 pi over 3. But we're also interested in this angle, which is pi plus pi over 3, also known as 4 pi over 3. The other half says secant x minus 1. So add 1 to both sides. So where is secant equal to 1? You can also say, well, the reciprocal of that. Where is cosine equal to 1? Where is cosine equal to 1? Oh, 0 degrees. So x equals 0, 2 pi over 3, and 4 pi over 3, and we only had to solve for it between 0 and 2 pi. Alright, here's the last problem. So pause the video, I'll let you think how to solve this. And then we'll go over it together. So here, I decided to square both sides. So I have 1 plus cosine x equals square root of 3 sine x. I'm going to square both sides. So I just, let's see, FOIL. So first, so I have 1 plus cosine x plus cosine x plus cosine squared x. So it's just 1 plus 2 cosine x plus cosine squared x. And then I square the right side. It's just square root of 3 squared is 3. Sine squared is just sine squared x. Okay, now I substitute in. I know sine squared x is just 1 minus cosine squared x. Distribute out the 3. Alright, so I have 3 minus 3 cosine squared x on the right side. I just rearranged the left side so it was in order from highest power to lowest. I move everything from the right side to the left side. I know there's a common denominator, so I divide everything by 2. Alright, so here's where I divide everything by 2. And then I solve, I factor it out. 2x squared plus x minus 1 equals 0. So I'll have 2x minus 1 times x plus 1. So I fill that in. 2 cosine x minus 1 times cosine x plus 1 equals 0. So I know cosine of x equals negative 1. Well, that's going to be at pi. On the left side, where is cosine equal 1/2? Well, that's positive. So that would be at pi over 3 and 5 pi over 3, except we're not done. I need to plug in and see if this is actually true. So I need to plug in for all these values. So I'll go ahead and do that. You can pause the video and double check your answers. Since we squared, we have to check for extraneous solutions. So here you can see that I plugged in for all my values. So I plugged in pi, it matches on both sides. When I plug in pi over 3, it matches on both sides. But when I plug in 5 pi over 3, it doesn't match. And that's totally because when I'm in the fourth quadrant, my sign is negative. So it screws everything up. All right, good luck. Let me know if you have questions. And that's it for today.